Saxon Algebra 1, Lesson 5. Greetings, my students. It's another review day. We're starting off our third week of classes, and we're picking up the pace a bit. So we're going to have a new lesson every day. So odds only for the homework. Each day do a different day's lesson. No more odds and evens or however you were doing it. Odds only. Please do the practice problems and let me just write this down. Always do the practice problems, all the practice problems, and then we want to do the odd problems in what John calls the problem set. That is it for the rest of the year. We should be on this jam. Who knows, something crazy might happen, like, I don't know, a worldwide pandemic or something crazy. No, just kidding. That already happened. There may be a time when I change this, but that would be rare. This is our pattern from here on in. Okay, let's dive in. Today's lesson has 3 different topics. The first one is sets. The word set just means, as it is in regular English, it's a collection of things. Now, we talked about sets the other day. Let me show you the lesson. Remember when we did all of this whole thing? Let me just get these pages out of the way without losing my place. This is what I'm talking about down here. We talked about the counting and the natural numbers. That was when you were a baby and your mom would count 1, 2, 3 on your little piggies. Then you learned about 0 and you learned about the whole numbers. Integers are negatives as well as positives, but only just the happy numbers. Then we got into the bits. We got into what we call rational numbers, the fractions, the decimals, and the percents. This is where your hair started standing on end, right? And then we have irrationals, which are numbers with repeating decimals that go, non-repeating infinite decimals. Rational numbers, it's okay if they repeat infinitely as long as they repeat, right? So repeating decimals, non-repeating decimals. Those are all real numbers. These groups that we talked about, that's what set means. This is the set of counting numbers, the set of whole numbers, the set of integers. So the word we now are learning about, you already were using here. We just didn't use that word per se. Another way that we can write what we did on that in that chart, we can say the natural numbers, the set of natural numbers. This is another way to write it. This is set notation. We write what the thing is equal to, and then we use pointed parentheses and the 1, 2, 3. And then again, we know whole numbers just means we add the 0, so we can say the set of whole numbers is equal to 0, 1, 2, 3. And the 3 dots are official mathematical terminology. It's not just when someone else is writing their text to you. That actually means and so on. And then we can also say the set of integers is equal to, and we usually do the dots to show that they go infinitely in the minus direction. I ran out of space, so I just started my dots there. All right, so that is what the word set means in mathematics. It's a specifically defined collection of numbers, all right? And this is the way that we can write it. It's called set notation, all right? That's all this is. It's just a certain way of writing it that mathematicians have agreed upon. Okay, that's enough about that. Let's talk about absolute value. Absolute value is a very simple idea, and later I'll explain the philosophy or the theory behind it, which is also pretty straightforward, but I don't want to confuse you in that right now. What I want you to know is that absolute value means everything comes out positive. No matter what you put into the positive value lines, I'll show you those in just a minute, it comes out positive. Do you have one of those people in your life who's just the most positive and sunny and upbeat person, and no matter what happens, they just see the bright side? That's what the absolute value signs are, right? Their house gets destroyed by a hurricane and they go, that's okay, I needed to vacuum anyway, right? Just relentlessly positive. That's what absolute value notations are. So if we put a negative number inside of an absolute value sign, it comes out positive. If we put a positive number inside, these are the absolute value signs. They're just straight lines. Mine are a little angled. They're just meant to be perfectly straight. This also comes out positive, all right? So it doesn't make positives negative. It makes everything positive. All right, and John shows a bunch of examples here. Let me just show you in the book. We don't have to do them all, write them all out. 0 equals 0. There's no way to change that. -5 becomes +5. -7.12 equals +7.12. So decimals don't scare it. Decimals don't change anything. Positive number stays positive. Here's a positive decimal staying positive. And here's a fraction. Fractions don't bother it either. It's just relentlessly positive. It is Susie Sunshine. So what I want you to imagine whenever you see those lines is that they're the rays of the sun. And absolute value is like Susie Sunshine, making everything positive, all right? Here are a couple examples that we can do that are pretty easy. They're kind of like those ones we just looked at. Simplify a minus, whoops, that should be straight. It's not a parenthesis, it's just a straight line. Absolute, and we read this, the absolute value of -5. Well, relentlessly positive, right? Yay. B. Now this is where it gets a little bit trickier. Absolute value of, that's the number 11, -2. We have work to do inside the absolute value signs. So what we do is we do the work first before we take off the absolute value signs. Okay? So they're kind of like parentheses in that respect, where if there's work to do, do that first. So this becomes the absolute value of 11 minus 2 is 9. Okay, now we simplify it by taking off the absolute value signs. It's just plain 9. All right, and then we have one more, C. I'm going to give a little bit more space here. This has got a minus on the outside of the absolute value sign, and then there's work to do on the inside. This works, the absolute value signs here work just like parentheses do. We cover it up. We find this, 20 minus 2 is positive 18. Then we put that back on. Okay, now we cover it up again. Absolute value of 18 is positive 18, but this minus sign is outside of the absolute values, so it stays in place. So the answer to this one is negative 18. I didn't box my answers. You guys, I'm sleeping on the job, aren't I? Let's make sure I got it right. 5, 9, negative 18. Yay! So everything that comes out of the absolute value signs is always relentlessly positive, but if you have a minus sign chilling on the outside, then he can turn things after the absolute value signs come off. Okay, that's enough about absolute value. We'll be using that in a lot of problems, and I'll talk about it. It doesn't really get any harder, but we get more complicated expressions to simplify inside of the lines later. Okay. Adding signed numbers. We talked about this before, last year. What it means is that we now appreciate the fact that every number can be positive or negative, and we can add them, but sometimes it's kind of like subtraction, isn't it? Because we're saying 3 minus 5. We're combining those two numbers. So this is what we're talking about learning how to do. John goes through drawing a bunch of pictures that kind of look like football fields to me. I don't like his pictures. I'm gonna be honest. I love you, John, but your pictures for adding signed numbers don't do it for me. What does it for me is the meadow. And I'm pretty sure we went through this last year, but let me talk about it. Imagine you're in a meadow. And as you're walking along, you're enjoying the grasses growing and the little flowers springing up here and there. And there are some little, here's some more grasses, some more flowers. And there's some little butterflies fluttering by, right? It's a happy, happy place. And you're walking along through the meadow and you come to a hole in the meadow. And you come up to the edge of it and you peer down, and it's quite a deep hole. In fact, you can't even begin to see the bottom of it. And standing up in the hole is a ladder. As you look very carefully at the ladder, you notice that there are, what are they called on a ladder? They're steps, right? The steps of the ladder. There are steps going up as high as you can see, infinitely up into the clouds. And they also go down as far as you can see, down the inside of the hole. And even from where you're standing up there at the ground, you can see that the dirt helps you see the roots of the plants, right? You can see the roots that are growing down here. You can see little wormholes with little worms squiggling in them. There's even an area, I'm not gonna be able to draw this quickly in a hurry, but here's a little mother bunny. Asleep in her nest. There she is, she's sleeping. She's happy, she has eyelashes. Okay, so we can see little animals. That's her tail. Oh, and then her nest. Her nesting materials are around her because she made it cozy. Okay, so there's Mother Bunny in her nest. All right, there's baby bunnies, but we can't see them. She's hiding them. Okay, so we can see all kinds of interesting things down here in the hole. But when we look closely at the hole, it's a beautiful old polished wood ladder that looks like it's been here for ages. And attached by each step is a little brass marker with a number on it. And as we look very carefully, we realize that this step that's even with the ground has a 0 on it. And as we go up, the numbers continue to grow, one with each step. And as we go down, we see that they decrease, one with each step. And what we realize is that this ladder is essentially a number line. Right? We usually draw our number lines this way with 0 in the middle and then negatives and positives. Somebody just picked up a number line and turned it on its side and put it in the hole so the negatives go down and the positives go up. Now, that's cool. I want to show you that it keeps going infinitely. I'm not going to draw it infinitely because, you know, life is short. But it does go infinitely, and we imagine it going on and on and on and on and on. So what we do is we are going to use this ladder in the meadow as a tool for adding signed numbers. Let's look at the first example. And it says use directed numbers and the number line. That means this, all right? It's our version of this, to add +3 and -5. That's how John is giving us the information to start. Okay, notice I just happened to pick the very same numbers. That's crazy. All right, so what we do is we go climb on the ladder and start here. And, okay, so we climb up to +3 on the ladder. Here we are at +3. Now, this tells us how to move. So we start at 3, and this tells us to go down because down is negative, up is positive. We want to go down 5 steps. 1, 2, 3, 4, 5. And so we end up at -2. Now we're going to come up with some rules so that we don't have to think about the meadow every single time we add these numbers, but for now, we're just working out our problems on this meadow ladder. In the meadow is what I like to say. Okay, let's do another one, 5.3. Use directed numbers and the number line to add -5 and +3. Again, we're not writing these as math problems yet, it's just a sentence. So again, we start at -5, all the way down here, and then we go up 3. 1, 2, 3. Oh, look, it's -2 again. Okay, start here. This is how to move. Example 5.4. I'll do that one over here so that we can still see our ladder. This time we're using directed numbers and the number line to add +2 and +1. Now, if we stop and think, we go, wait a minute, we did that in first grade, come on. But let's just try it and see how it works on the ladder, see if we get the same answer. +2, that's where we start. And then we move up 1. We always associate up with positive and down with negative. So we're at +2, we go up 1, yeah, it's 3. It's really easy, right? If you want for your answers, you can write +3. All right, so let's go on. There's a couple more. Yeah, we just have a couple more examples and then we're done with the lesson. All right, example 5.5. Again, use directed numbers in the number line to add -2 and -1. Now I happen to have another copy of my meadow right here. -2 is right here, and then we're supposed to add -1, so that means we go down in the hole further. Also, look, it becomes -3 is our answer here. Example 5.6. Look, this time our presentation's a little different. It says use directed numbers in the number line to add these numbers, and then it shows us this. -4 plus +2 plus -1. Okay, so it works the same way. This tells us where to start, and then this tells us how to move. Remember that in deciding how to move, we need a sign, positive or negative, and then we need a number of steps. We need a direction and a distance, right? So we'll do it the same way. I'm gonna scoot this up just a little so you can see this. So we start at -4, then we go up 2, down 1, up 5. 1, 2, 3, 4, 5. And that gets us to +2, right there. All right, so this isn't rocket science. Don't worry about trying to think of this any other way except climbing up and down this meadow, or the ladder rather, and you know this because we did it last year. We'll find that there are some simpler ways to do this than going on a hike every time. But for now, we want to make sure that we're really clear on this idea and how this ladder in the meadow works so that we can refer to it later when we're feeling stuck on a problem. That's really the gift of this, is that if your brain dies in the middle of these calculations, you'll have something to fall back on, and the rules that I'm going to give you later will make a lot more sense. Okay, guess what? Lesson 5 is over. Yay! Do the practice, all the practice, do the odds only, and I'll see you tomorrow for lesson 6. Thank you, goodbye.